Welcome back, Math 30, and in this video I'm going to show you one example of a slightly more involved optimization problem. And just so you know, this is very similar to a question that was on the final exam last semester. Last semester's final exam will be available to you, or already is available to you, to study from with answer keys so you can practice, and there's one that's similar to this question. This is also similar to a problem that is on your homework. I'm not going to do the complete problem, but I'm going to help you set it up and think about how you can start approaching these kinds of problems. This can help you with your homework and maybe even help you with a final exam question. So let's get right to it. Consider the following problem. A farmer with 750 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible area of the 4 pens? So this implies we're going to be maximizing something, and maximizing what? Maximize the area. So I know I need A equals something, and I need to maximize that area. I need a picture here, and this is where you need to start thinking, you got to reread, you got to think about, okay, what is it saying here? So notice the fencing is fixed. So 750 feet of fencing is fixed, constant. So we can't change that. And we want to enclose a rectangular area. Let's just draw a rectangle. So we need fencing around the rectangle. But it says that we also want to divide it into 4 pens. So inside of this area, we divide it into 4 pens. Well, how would we do that? We would need to have 3 inner dividers to divide into 4 pens. So we would need fencing everywhere where we drew a line. You notice I could have drawn it this way. I could also do the pens like this. Yeah, okay, so can you just see intuitively that if it it looks like the one on the right would use more fencing than the one on the left because the ones in the middle are going the long way. So if I actually drew this so that the fencing was equal, it feels like the one on the right would have less area. But that's okay. But the point of this picture is for us to, and so we might be right. So when we're doing this, we kind of start building our intuition about the problem, and we're kind of doing some drawings, and we start to label things. I know, so it'd be good, by the way, to start to label stuff. And there's a couple different ways you could label things. You could label this with a variable, like y. And you could label this with a variable like x. You could do base times height, although it's not going vertically. So then that would just mean that the area would be x times y. The full area of the full situation would be x times y. And the fencing would be the total. I'm going to put F for total length of the fence. The total length of the fence would be, it's 2y because we've got this whole length of fence, that's y. This whole length of fence, that's another y. So that's 2y. Plus this length x is here, but there's 1, 2, 3, 4, 5 of those. So there's 5 length x. So this is an equation for the length of the fence. And this is the area. So this is me just sort of deconstructing the question and kind of trying to understand what's going on. Now, in the textbook and in WebAssign, they ask some questions that they don't actually have you input, so you don't need to put it in for credit. but it is something that you could consider doing. And so I'll help you with one of the questions. It says draw several diagrams illustrating the situation, some with shallow, wide pens, some with deep, narrow pens. They're trying to get you to kind of play with the ideas and do a drawing and think about it. It's kind of what I already did. Find the total areas of these configurations. Does it appear that there is a maximum area? If so, estimate. We could just get the idea. But I just wanted to show you that there's a couple of different ways we could end up drawing this. These examples here have concrete numbers. And notice, and I actually did the calculations. So this one matches this case. There are five fencings of length 50. That's 1, 2, 3, 4, 5. And then there's 2 of length 250. And you notice they add to 750. And you'll notice that it's the same for all of these. They all add to 750. But the inner parts and the long side are different in each case. But you notice that having these different lengths changes the area. In this configuration, the total area is 12,500 square feet. In this configuration, let's see, which one is this? This one is the 120. So this is this guy. And this one is this one. Yeah, like that. You can see that with these long narrow inner fences, this is very inefficient if we're trying to maximize area, and we only get 9,000 feet square. This one and this one both are 2 different ways to get 12,500 feet. You would think that maybe there's something in between these two that might make it more than this. Like if we slightly lengthen 50, maybe if 50 was 60 and 250 would have to decrease. I don't know. And then they ask you to draw a diagram illustrating the general situation, introduce notation, and label the diagram with your own symbols. You don't need to turn this in WebAssign, but this is what you would need to do on an exam to really help you out. And we did it on the previous page, so I'll just kind of like, for the sake of completion, I'll do it here. And I think in WebAssign, because they're looking for a specific answer, they're going to tell you how to label these. And I think, if I remember right, they want you to label the long side Y and label the short side X. But they tell you, or label this side X. They tell you how to label it. Yeah, that's it. Write an expression for the total area. A is X times Y. And use the given information to write an equation that relates the variables. Well, actually, I could also represent the fence. The fence would be 5x plus 2y. That's the total lengths of the fencing around the outside. What? Good. So fencing. Now use the given information to write an equation that relates the variables. So here's where what we want is we want A to depend only on one variable, like for example, X. And over here, this needs to be stuff that only has X. In other words, we want A written explicitly as a function of X. And then we need to find A prime and find where A prime is maximized. Then you maximize A of X. And I'm going to let you do this. You need to write an equation. What they mean here, use the given information to write an equation that relates the variables. They're meaning to do this. Find an equation where it's A of X is equal to a function that only uses X. And in the notes that I will release when I'm done with the full section, I'll have a complete worked out answer here. I don't want to do it now because this is similar to what's on your homework. I want you to try and help go with the setup that I just explained. And I want you to use this video to get you started. Your numbers are going to be different because WebAssign changes things, but there's a similar problem similar to this. Okay, so next step would be to take these two equations and combine them into one. and get rid, and by the way, um, uh, yeah, so it's possible. Okay, so this, I took this question from the textbook. I don't remember how it's exactly worded in WebAssign, so sorry about that. But what I will say is it's possible what they want is they want, in this question, it's possible what they want is for you to write this equation that relates the two. So you have to read how it's worded. And that would be 5x plus 2y equals f. But actually, do you remember that f was constant? The amount of fencing is constant. So we could plug in, let me go down here, we could plug in 750. So this is an equation that relates, this directly answers the question. Use the given information to write an equation that relates the variables. And here, use your previous work to write the total area as a function of one variable. I forgot that the textbook worded it like this. So sorry, I think I said something slightly wrong previously. What do we have? A equals xy, and we have the fencing, 750 equals 5x plus 2y. I think that's what it was. Now, we would get, this is what we want. We want all of this. This is ultimately what our goal is. So I'm not going to get rid of this. This is really what you want because this allows you to find a derivative. But what I will do is I will copy this onto the next page and copy that and move on. And then what I'm going to do is paste it here. This is our goal. Okay. Now I'm definitely not going to do any more because I want you to do the substitution. I want you to maximize the area with the given function. Okay, that's all I'm going to do in this video. It's just to help you with that last problem on the homework, kind of get you started. It's going to be more like this in a following assignment, and I will do some videos just helping you set up. The setup's always the hardest part. I want to help you through some really classic problems that could end up on the final, and they also teach you a lot of important things about how to set up these calculus problems. All right, see you next time.